All right, I don't know if it'll record up here, but everyone wanted to say hi to all the losers that didn't show up here. No, you guys are not gonna tell everybody who's here? No? No, they're embarrassed because they're not gonna watch it anyway. Probably not. I don't even know. Sometimes when I have three screens, it sometimes records like half of that screen and half of this one, so I'll see what I'm done if it records. All right, so we're going to find the limit as x approaches a. So we're going to do the f of x minus the f of a formula, and we're going to derive the derivative formula. Okay, so we're going to derive that formula first. That way we don't have to calculate it at -2, then calculate it again at 12. Okay, so plug in, first of all, your f of x. So we have 5x squared plus 7x. Okay, then you're going to plug in your f of a. So we have minus, it is important here to put parentheses there. And we're plugging in f of a into, so a is going to go into this formula right here, and we get x5 a squared minus 7a. And that's all going to be over x minus a. Alright, so deriving it from there, I distribute my minus sign. We have 5x squared plus 7x minus something just went up with my ruler here. See if it writes this time. A squared plus 7a. That's all over x minus a. Now, we're going to come up here and I'm going to put together my 5's in here, so I can factor the GCF out, and I'm going to put together my 7's together. So I'm just going to reorder this slightly. So it's 5x squared minus 5a squared. Plus 7x plus 7a. This is where the math gets a little tricky.
Remember, by the end of the period, I'm going to show you a shortcut to doing this problem.
If I told you right now that the derivative formula is going to be that all done, because I'm looking at this right now and I can figure it all out, you're going to have to think, how do you do that? Well, I'm going to group these two together, and I'm going to group those two together. I'm going to factor a 5 out of this. This is x squared minus a squared plus 7 times x plus a. And that's all over x minus a. I still need to find a way to cancel out this x minus a in it. So if I come up here and I see a difference of squares, right here, this turns into 5 times x minus a times x plus a plus 7 times x plus a. Going back here to an easy GCF, you guys see when I factored out this 5 right here, how we divided it out of both of them, and just came up with this x squared minus a squared. Well, in this part right here, this, both of them have an a plus x or x plus a in them right here. I'm gonna factor out of this thing x plus a. When I factored out of it, I basically divided out of this and I divided out of that. Okay, does that make sense? When I came up here, did you guys know how I kind of divided it out and I came up with that right there? So if I come over here and I divide an x plus a out of this, doesn't that just cancel that part out? And you're left with this 5 times x minus a. And you factor out an x plus a out of this, and you're left with just 7. That's what I did wrong. You can see what I made a mistake. Backtrack, see where there's a plus right here? I put the wrong thing right there. Back up there, which is gonna change this to a minus right here. So this right here changes to a minus right there. So this part right here still factors. X minus a times x plus a. This now has an x minus a in it. Here's how I knew I made a mistake. My x minus a down here was supposed to cancel with something up here. So when I factored out, okay, this out of here, I needed to really factor an x minus a out, so it's going to cancel with this one down here. So if I factor an x minus a out of here, I'm left with 5 times x plus a plus 7 all over x minus a. X minus a is canceled. And we have defined the limit as x approaches a. 5 times x plus a plus 7. Which I guess this could simplify to 5x plus 5a plus 7 if you wanted. Okay, the main thing is this. In place of the x, right here, I gotta substitute an a in there. So this ends up being 5 times a plus 7. 5 times 2a plus 7. 10a plus 7. Now I wanted to know what is the derivative formula for x. All you have to do with this a is right here, replace the a with an x, substitute the x in for the a, and here's your derivative formula. That will help you find the slope everywhere on that equation. Oh no, you guys are looking at me thinking, how did you guess that? Told you, there's a shortcut to all of this right here. Okay, when it's just a simple equation, like we had right there. So we wrote the equation of the tangent line. There you go. There's the equation of the tangent line. And y equals 10x plus 7. You want to find f of, let's see here, negative 2. And then find f of 12. You don't have to do this stuff twice. You just now have to use the formula right here and do 10 times negative 2 plus 7. You got negative 20 plus 7, which is negative. And the same thing right here, 10 times 12 plus 7 is 127. So the slope of the line at negative 2, the slope of the line is negative 13 at 2. The slope of the line at 12 is really pretty steep. This is a quadratic equation. It looked like that. So if I come over here at 12, okay, let's see how that's a pretty steep line slope right there. But if I'm over here at negative 2, there you go, there's my slope right there, negative 2. Not as steep. I have a negative steep. Same thing. Example 3. Let's see if you guys can get the derivative for me. Big long process. Looks on your faces, you're like, how much longer are you going to torture me for? Yeah. No longer. Alright, so we said to do number 1 right there on that worksheet. So you have to find the formula for this one. Actually, what does it say? Do not find the formula. So all you have to do on that one right there is you're going to plug into this formula, okay, right here, what they tell you to plug in for x. 3. So you just find the slope flat out at 3. Do you really need to do all that work if you only have to find it at one point? Probably not. Did you guys agree that doing all that work was not very fun when we had to find the formula? It's long and tedious, and look how long this thing took right over here. Yeah, that's all the work for number 3 right there. Just finding this equation right here. If I only had to find it at one point, don't worry about finding the derivative formula. If you have to find it at multiple points, which we'll do here next, we're going to find the derivative formula. So do the first couple there. I'm going to put number 1 up on the board here in a little bit, so anybody that's watching this can follow along. You probably have to find on your own sheet of paper to find room for it, because I don't think all that work will fit between space 1 and space 2. So we're going to and a function. Okay, I have this one, which was 2x squared. Was that minus 1 or plus 1? No. Minus 1. So you're plugging in. Okay, that equation, I guess I should put that there. 2x squared here. And in for this problem right here, we're plugging a 3. We're going to plug a in because we're not asking to find the derivative formula. We're just trying to find the slope at that one point. So just don't forget, you got to put parentheses around that, okay, so that you are subtracting the simplified version of it. 2 times 3, 20 squared minus 1. All over x, and 3 is in the middle there as well. Minus 3. we're supposed to find the limit. So I'm supposed to plug in 3 into this equation to find the slope at 3. But if I plug in 3 here, I still get it to fail. I get 0 in the denominator. So what do we have to do? Yeah, GCF. Okay, we gotta call our superhero. Okay, they come up here. We factor out a 2 out of this. Remember, that's like dividing 2 out of this, dividing 2 out of that. I didn't know. That was supposed to be an x minus 3. That was supposed to cancel with this x minus 3 up here. Difference of squares. Okay. So this part right here is an x minus 3 and an x plus 3 is what that right there cancels to be, our factors out to be. And that right there is going to cancel with that right there. So now we are doing the limit as x approaches 3. I got 1 right down here in the denominator, and I have 2 times x plus 3 in the numerator. So my limit is 2 times 3 plus 3. 6 times 12 is, there is the slope. This is the slope of the tangent line at x equals 3. That's what a derivative finds. That didn't take long, did it? Okay, let's skip to problem number 11. You want to do that thing right up there 5 different times? Because at number 11, they're asking us to do when x is -2, and then find it when x is -1, and then find it when x is 0. So I'm going to have to do this, all this work, 5 times. Unless you find the formula first. Alright, so what did I say that number was that we're doing? Number 11. Okay, so the formula. Tell me what the formula is here. Say that again? Yeah, number 11. X squared plus 2. By the way, the derivative formula is going to be 2x. That's how easy it is once you learn the formulas. That's the shortcut. Okay? But we don't know the shortcut yet, so we have to use this. I know I'm irritating right now. Just shut up and tell me. That is really all of what first semester calculus is about, is learning half the shortcut formulas. Okay? Learning that when you have this type of equation, here's the shortcut formula. If you have this type of equation, here's the shortcut. So you don't have to do this garbage every time. That's what calc is. Finding the rate of change of objects of different types of curves. Alright, so our first part right up here is, okay, we go right down after this. X squared plus 2. Okay, we have minus. They were plugging a in. So this is a squared plus 2. Okay, all over x minus a. We're searching right now for this derivative formula, which I already told you is going to be 2x. Okay, 2 times x. Okay, that's what this, all this work that we have right here, that final, when I'm done doing it, is going to come out to be that. Alright, let's put my like terms together. So first I have to distribute this. I have x squared plus 2 minus a squared minus 2 all over x minus a. And if you distributed your 2, what happens? Or you distributed your minus, what happens to the 2's? They cancel. So I have x squared minus a squared all over x minus a. The whole purpose notice was to cancel right here, can I do this? Can I just cancel there, cancel there, cancel there, and cancel there? I don't know, you guys roll your eyes right now, I think we're doing that. Yeah, it's not funny anymore. Alright. X minus a, x plus a, difference of squares, is what that is, x minus a, oops, that's not an x, that's an a, and the x. So I have, my formula, okay, right here is going to be the limit as x approaches a for, this is all I have left right there, is this x plus a. You have to substitute in this a right where that x is. And you're going to come up with a plus a, which is 2a. And I wanted the derivative in terms of x. Is that what I guessed it was going to be? Right. Okay, my board just underlined. Okay, but now go ahead and find the slope at all 5 of those points while I align my board right up here. You can find it at 0, you can find it at 1, -1, 2, whatever those things were. Okay, I'll align it and I'll do my work here in just a second. So we're going to find it, and when it approaches it at -2, -1, -2, -1, 0, 1, and 2. Alright, so we're going to find f of -2. 2 times -2 is -4. I'm going to find f of -1. Oh yeah, that's going to give me 2 times -1, okay, which is -2. And I'm going to find f of 0. 2 times 0, which is 0. F of 1, which is 2 times 1, which is 2. And f of 2, 2 times 2, which is 4. Why did I find that? So I didn't have to come up here and do this from the last problem 5 times. You try, okay, right here, number 2 and number 12. And then I will show you guys a shortcut. And I'll let the rest of the class finish the worksheet. Okay? Do you guys do 2 and 12? And the seniors or juniors that are in here too, finish this worksheet out. Okay? And I'll show you the shortcut, and I'm not going to record the shortcut yet, because I already sent the shortcut out to them.